I'm Dr. Janet Six, Senior Product Manager here at Tom Sawyer Software. And today we're going to be discussing how to use Tom Sawyer perspectives and Tom Sawyer explorations to support investigations. And this is going to include discussions of our new FBI case study, which is available today on our website. We're also going to discuss how to integrate and federate data across an enterprise into a graph model, which is optimized for data visualization and analytics, and including the integration with a wide diversity of sources, including graph databases, SQL, RDF, REST, JSON, Excel, and structured text. And you can use the advanced visualization and analysis techniques in Tom Sawyer perspectives and explorations in order to uncover hidden patterns and relationships. So we're going to look at several different examples today. And the first one we are going to look at is of our crime network demo. And so we see here on the screen a screenshot of a dashboard that we made from one of our example applications. And you'll see here on the left side that we have a tree view, which has settings for the application, as well as several filters, which I'll show you here momentarily. We also have multiple drawing views, which we'll be looking at, a map view, a timeline view, which shows how the data changes over time, which we'll see here in a moment, as well as some charts. So you'll notice here when we look at the example application running that we have options on how to create our dashboard and give a different look and feel dependent on our different use cases. So here we have the application that is up and running, and this is again an example application which we built with Tom Sawyer Perspectives, which is an SDK and low-code graph analysis and visualization platform. And this is available on our website for you to try as well. So over here on the left side, we have these interactive tree views where we can, for example, apply filters to other views here in our application. And we'll see how these work here in a moment. We also have a couple of drawing views, and we'll talk about how these are different here shortly, as well as an incident map. So we see where are these crimes occurring. Down here in the left bottom corner, we are going to see, and let me zoom in here a little bit. We can select an item here in our drawing view, and we can see more details about this particular person or a particular crime in our inspector view here in the left bottom corner. And then down here, we have several different views available in different tabs. So we have a timeline view, and we'll see how this works here in a moment, as well as several charts, so we can understand more about what is happening here in our crime network. Okay, so let's go back out and see how do we use this. So first of all, let's talk a little bit about what is it that we're looking here in the drawing view. So in the drawing view that we're looking at now, we are seeing the criminals and the crimes they committed. And we're looking at all of our data in this example. Now, maybe we don't want to see all the data. We want to focus into particular types of offenses, which we can see here in our tree view, which type of offenses that we have. Or we may want to focus in on a location, a particular districts where crimes have happened. So we have the ability here as a user to select which precincts we want to see our data for. So I am going to deselect a couple of these, and you'll notice on the right side how the visualization automatically updates. So we are now looking at the particular incidents and criminals involved in the southern and the western precincts in our location. And so you'll notice how when we had changed our selection here in our filter, how the drawing view automatically updated, as did the chart view. So all of the views are synchronized in perspectives. If you make a change in one view, you'll see the synchronization of that data in the other views as well. So we are showing here how to use those filters interactively by user, but you can also apply filters programmatically as well. Okay, now sometimes the data that you see in the original data is not exactly the data that you want to study. And we're going to talk a little bit more about that. So here we are, again, we're in this people and incidents drawing view, and we're looking at our original data of criminals and the crimes in which they were involved in. And if we are wanting to study the social network, for example, this is not exactly the data that we want to study. We want to see a connection between two criminals if they committed a crime together. And so that is going to be important here in our second view, which is the social network for the crimes that we are studying. So now you see how I updated the filters. And so now we're going to see our entire social network. And let me zoom in here to part of it. And so now we're seeing a connection if we have criminals who are working together. And so now we're going to apply a couple of analytics so that we understand some of those hidden connections that were hard to see in our original data when we were looking at criminals and the incidents together. Now we're just going to focus in on just the criminals and see who's working together. And so let's say that we have a investigator who has found two people of interest. And so we're going to select these two criminals interactively. And again, if you want to do this programmatically, Perspectives allows you to do that as well. So I've selected these two people of interest, and I'm going to set a hop start, meaning that for our analytics, we're going to show that these two criminals are especially important. And we're going to perform a reachability analysis. So we want to find out more about the social network around these two people of interest. So we have the ability to have many settings in a lot of the analytics that's provided as part of the analysis suite and perspectives. And so what we want to do here is that we want to focus in on um, the people closest to these particular people of interest. And so I'm going to set the hop length mean to 3, meaning that we're going to look at a distance of 3 hops from each of these people of interest. Okay, so now I'm going to apply analytics in order to show the reachable network of these people of interest. And so now we're focusing in on a key part of the social network. And that's one of the keys to effective graph visualization and analysis is to be able to usefully narrow down the data that you're looking at so you can find those details that you need specific to your investigation. So now we're looking at the piece of the crime network that's closest to these two individuals of interest. And you'll see those two individuals here of interest here with the red nodes. Okay, so now we can see, well, looks like a pretty active part of the crime network. Who are the most important people in this particular crime network? So we're going to run another type of analysis. And you can run several types of analysis in sequence, as we've done here. So we ran the reachability analysis, and now we're going to run a centrality analysis. So we're going to apply betweenness centrality analysis. And what that shows us are the people that are on the super highway of information in the network. So they're the ones who may be seeing a lot of messages passing back and forth between paths of people in the criminal network, for instance. So now notice that some of the nodes are larger. So the larger nodes are the key people in this part of the social network. And you'll notice that, one of our original red nodes is here, and the other one of the original red nodes that the investigator found is here. But we found a new node that we made large here. So we found this node with our centrality analysis. So this is an example of the investigator working together with data-driven analytics to find hidden results. So the investigator knew about this person. And by following the investigation, applying some well-directed, data-driven graph analysis, we found this key person in the network. So the understanding of who this person was with the analysis led us to a key finding that we didn't previously see before. And so this is an example of how to take criminal data and to compute a graph for a particular use case. In this case, we want to understand the social network, and then to apply a combination of human investigation with data-driven analytics to find key results. And then what you see here can be presented to stakeholders and decision makers to show important findings. In this case, in order to have a maximum disruption of this part of the criminal network, you may want to specifically try to stop or arrest these particular individuals. Okay, well, at this point, I'm going to hand over the webinar to our CEO, Brendan Madden, who's going to discuss a little bit more about our brand new FBI use case.
Thank you, Janet. Nice presentation on the crime network demonstration. So I'd like to talk about the solution we built for the FBI, and what their problem was, and how we worked together with a number of other software vendors and the system integrator to build the solution for the FBI. So the problem is there are approximately 18,000 independent law enforcement agencies around the country. That can be like city, county, statewide, various local agencies. What's happening is, there's all sorts of arrest record data. It's a very elaborate. There's a very elaborate data that the government wants to collect. So the problem is each of these jurisdictions often has their own separate case management tools, or a custom developed law enforcement system, different data source types, and everything. So the government developed something called the NIEM model, National Information Exchange Model, which is it's like an XML representation of all the all the arrest data, all of the attributes about the suspects and the victims, all their does a person have a tattoo? Were they carrying a knife? Did they have a gun? Was the suspect, was the victim injured? Hair color, eye color, all sorts of tattoo details, etc. So all this data is collected, about cars and time of day, when the arrest happened. So there's time data, attributed data, location data. So this NIEM is a national XML representation. And so the index program was developed in 2008, and it, there were problems because all of these independent agencies are essentially silos. People, someone, might have been arrested in Kansas, and they might have also been arrested in Missouri, the same person or with the same vehicle or the same set of people or different, but the local agency would only have the Kansas data or only have the Missouri data, for example. And the idea of index is to have, a central, a search environment essentially to say, you can enter a person's name or, details of the license plate or whatever, and it'll pull up the data across jurisdictions. So people, might have, yeah, maybe there were gangs, I know they were talking about, there were examples, of gang activity like in Albuquerque and Detroit, and without index, you couldn't see that, there were actually networks operating, the same network was operating, for instance, in New Mexico and Michigan. So it would bring up these networks, and then the detectives and the investigators can drill in and work collaboratively with the other law enforcement agencies, so they could make task forces, and the task forces across different jurisdictions would work together to try to solve the human trafficking, the sex trafficking, the drug trafficking. So all of these things were multi-jurisdictional. And this so index was a voluntary system. So it there's, yeah, like I said, 18,000 agencies, and approximately, my understanding was approximately 8 or 9,000 of those agencies participated in index. So what they do is, on a schedule, they regularly upload. So they somehow they export their data from their systems and upload it in an XML representation that's standardized. That's the NEM. So they upload that onto the FBI servers at the CJIS, which is the Criminal Justice Information Systems Division. That's, CJIS is pretty famous. That's in West Virginia. And at any time, so this is a national, so it's uh, the detectives and investigators and the FBI itself all use the system, and it has a web-based client, and it had, they had a number of, Raytheon was the system integrator, and we worked in Maryland with Raytheon. They had vendors such as IBM, who did entity resolution. ESRI did the geographic maps. Tom Sawyer software was selected for link analysis and visualization and social network analysis. So we were the network representation. Autonomy was for enterprise search. Autonomy provided the search, and there was an Oracle database backend. It wasn't a graph database system at all. It was an Oracle SQL system. So I know they were later in the program. There were, graph databases were just coming online. So, and the system was originally developed, I think, in 2008. There was previously another visualization vendor who I won't mention, but they were removed, and Tom Sawyer was put in, primarily because our drawings were a lot better than, we specialize in like orthogonal drawings, symmetric or spring embedded drawings, circular layouts, hierarchical layouts. We have a fantastic labeling technology. So often there were labels along the edges and the nodes, and the problem was, the more simplistic layout technology of the other vendor. There, all of the edges, would be drawn under the nodes. You couldn't read the labels, so people don't realize the value of high quality layout technology that Tom Sawyer specializes in. So, and we also working with FBI agents, we kind of developed and perfected social network analysis algorithms. So, like Janet just presented betweenness. Well, that to an FBI, so we were doing like bullpen development with the other, so they had a very interesting set. It was very interesting to do the project because the system integrator set up like kind of a bullpen with all 5 or 6 subcontractors all developing for several weeks together. So they had a very agile kind of a deliver every week or several times a week, and then present to the the FBI agents who are all specialists in different kinds of crime. So it was a very interactive Scrum-like agile process, and so we would present our solution, and the agents would give feedback. Sometimes, like we realized like betweenness or degree centrality or clustering, that doesn't mean a lot to an agent, and but if you say betweenness is like, well, actually, who are the middlemen in the network? That they understand. So who is the, or if you speak in you know drug distribution kind of terms, like who are the distributors, who are the the guys in the neighborhoods. So if you make, if you so we tailored the whole social network analysis user interface for layman's terms. We developed all very nice like online help, so they could so people could go through, understand what these analysis were. So clustering was like groups, and you know how do you how do you break up a network? Well, you assign different field offices. I think there are like, with the FBI, there are like 52 field offices, I believe. So, for a complex national, drug case, if you're trying to, so they would assign different, so like the clustering we developed, you could say, well, I'm going to assign this field office to that cluster and another field office. You could look at it geographically, or you look at the network and the clusters that we would reveal. And they could, that helps assign different field offices or different agents or different jurisdictions to tackle parts of the network. And the middlemen would be, you could attack the middlemen or target them first. Just like in Janet's social network analysis, if you want to target a network, well, you'll take out the most important people in the network first, or try to develop a case against them. And so this is how they would go about breaking up, and the FBI said, well, I don't know how else you could attack these networks without having like really attractive link visualization. So the network representation is really essential. The data was absolutely huge. I mean, I mean, I'm not a database person, but the data was massive, and the search results would bring up the networks, and uh, and then Tom Sawyer was able to simplify the presentation, and permit people to target the networks, and they they track cases. They have case management systems at the FBI, and everything is a case, and they're trying, they have, thousands and thousands of running cases, and many investigators, trying to target them. And they said how essential, you know, how essential the network representations were. So we provided a lot of filtering views, like you see on the left. You could tune the search filters and things like that. And we also developed, so we actually chose an orthogonal layout representation for the end users, because the drawings we didn't choose like the standard spring embedder view that you see, among some other visualization vendors today. A few of the companies all default to the like a spring or network representation. We defaulted to like orthogonal layout with labeling, and we made very clean and compact drawings that they had never seen before. So they were, they called us a Cadillac system, like they were really impressed that it wasn't just like, limited like, some of the other visualization vendors are. So they really said we're like a Cadillac system, and we also used image map views instead of, so we had HTML canvas web views, but we also had image map, where server-side generation of the images and hotspots on the drawing. So the problem was that the detectives who use Index are often on, very old computers. They were using like Internet Explorer, So, you know, the so we used the image representation because of the performance. It helped the software perform even on very old computers. So there was a lot of tuning. So yeah, it was a very good way, I think, to develop the system. They let the specialists of each component of the system actually do the development. So it wasn't just throw it over the wall to a system integrator. They actually brought in each vendor on a consulting services agreement, for several months, over, like 1 month, and then develop the system for, rapidly in a month, and then call us back in, another month or two later and do it again and the system was built, but and it was, it was very good. It wasn't just a system integrator, but you really had the field agents and giving their feedback, interactively, which made it a, kind of a really interesting project for us. And so they didn't have, as much, we like Tom Sawyer has timeline views and charts and other technology, that wasn't in the solution. It was really tree controls, filters, search, link analysis, and so it didn't use our full data visualization capabilities, but it was, so this was, I get, we built this system, actually it's about 10 years ago now, but so we're finally producing a case study. But yeah, but we this was work we did 10 years ago. So, and okay, Janet, you can take back over. Yeah.
Oh, okay. Oh, thank you, Brendan.
Yeah.
And so wanted to let everybody know that this case study is now available on our public sector page. So when you go to the Tom Sawyer site, you can go to use cases and public sector. That takes you to this page. So you'll have more information about our support for organizations in the public sector. And then as you continue to scroll down, you'll see a place where you can request a copy of this case study here. Okay, so now we're going to talk a little bit about how we created this application, and then we're going to take a look at some other examples to support investigations. So how did we make this application? So I'm going to open the designer. So this is our low-code environment for creating graph visualization and analysis applications. And over here on the left side, you see in our project tree, the story of the application. So first you'll see the schema and the types of incidents and criminals and types of attributes that we have for each type of elements. I can zoom in here. So those details that you would see in the inspector and ones that were used to build the chart views and the tables and such. Well, where did that information come from? Well, we had to create a effective graph model. And by the way, the graph model can contain millions of elements, and then you take the appropriate subset of those and you put those into your drawing view or your table view or your chart. Okay, so continuing on down here on the left side, we have our data integration. And you can see more information on our YouTube channel, how you can connect to a wide variety of data sources. So you'll see here a list of the data sources that we support with perspectives. And of course, several of these support several different databases. Of course, there's many different types of SQL databases or RDF databases. RESTful endpoints, connect to a lot of different things as well. And so over here, I just have a little summary of some of the data sources that we support, these and more. Many of these you can do automatic schema extraction to help you build your schema and your graph model more quickly. And we also support commit for most of these data sources as well, so that you can uh, visualize and analyze your data and then make updates to your original data source or another data source as well. All right. So you can see again our YouTube channel where we walk through the steps of how do you create your application, add additional views, and deploy your application with Docker, Kubernetes, or AWS Terraform. See your first results in minutes. We have a nice video on that on our YouTube channel. And so, yeah, continuing down here, our project tree, then we have our graphs and our analyzer. This is where we do the analysis that we were seeing in the application. And then here is where you define the different data views. So you'll see we have a lot of different views in this application. We had multiple drawing views, we had a map, we had several trees and types of charts and tables, as well as an inspector. Then here's the part where we defined our filters and search. And again, if you want to see more details on how does filters and search work, we have a YouTube a channel with many videos on this. And of course, we're glad to set up a demo for you as well. And then to bring it all together into the dashboard, we have our view layout. And then here is where we define the look and the feel of your application. And so this is the view layout for the application that we were just looking at. But as we saw in our original screenshot when we first came in today, you can arrange these views any way that you need for your particular set of users or your particular use case. All right, so we are going to keep going on here, and we're going to see another example application that we built with perspectives. So I'm going to show our fraud detection example. And again, this is available on our website, on our graph graph application example page. Here on our website, you'll find this under use cases. and graph applications examples. And there's many, many applications that you can try, including the crime network and the financial fraud demo, which we're getting ready to look at now. So let's take a look at this. Again, this is an example application that we built with the platform. So you can build the application that is specific to your use case and your needs. So what we have here on the left side in our tree view is a result of background AI analysis and analytics. We were looking for credit card accounts which shared a suspicious amount of the same information and could indicate a potential fraud ring. And so we're going to take a look at one of these particular cases. And so now we're seeing here with the graphics that we have in our visualization, we can see at a glance by different colors, that we have several different accounts, and clearly we have a couple of phone numbers that are being used, and we want to find out more about, well, this does look suspicious. So now this is orthogonal layout, which is primarily the horizontal and vertical edge routing. But we're going to do a slightly different layout here. You see we have many options, but I'm going to go to hierarchical because I want to see more about the dependencies in our system. So as you can see here, the different layout styles are going to show you something different about your data. Now we're going to take this one step further. We're going to add swim lanes to our visualization, and this is going to show us a categorization of all of the data that we have. So I'm going to apply swim lanes. And so now at a glance, we can see how many accounts are involved, which phone numbers are involved, and who is sharing which phone numbers. And so we see some interesting activity over here. We see, we see several accounts sharing this phone number and this phone number. But then we also notice that some of the accounts are sharing the same IP address, and they're also sharing these phone numbers. And so there's something more for us to investigate here. So we can do this. I'm going to show this interactively, but again, if you need to do this programmatically, you can do that as well. We want to know more about this particular account. And so I'm going to say, show me the neighbors. So it's going to go to the database and it's going to find us more information about this particular account. And so you can see how perspectives automatically created more swim lanes for us. So in fact, well, we have a fraud alert on this account. That's good to know. And as well as we can see the transactions that were recently associated with this account as well. Okay, so there's definitely something suspicious going on here. We need to investigate further. So which merchants were involved? So we can select and again load neighbors, and we can find out which merchant was involved as well. So we can continue our investigation here by loading more transactions or finding out who else is involved with this particular merchant. Now you'll see as I zoom back out how the graphics changed. So as we zoom out, there's more detail. We needed to have a summarization of the data. And so you can see how the colors of the nodes got brighter because we were using a different graphic. And this is something that is sets perspectives apart from the competition, that you can have different levels of detail as you zoom into and out of elements to see a summary or to see very detailed views of what's going on with that particular part of the data. Okay, so now in this case, we found that this is suspicious in our investigation. So we're going to go and we're going to mark interactively this particular account as fraudulent. So you can see how interactively we were able to go in and mark this account as problematic. And so we can use this to share that information. We could write this fraudulent tag back to the original data source, for example, to continue our investigation. Okay, so now I'm going to show another example with Tom Sawyer explorations. And in fact, we're going to be looking at the same fraud data, but in a different way. So again, it's dependent on your use case and exactly what it is that you need to do in your investigations. So now this is Tom Sawyer Explorations. This is our no-code graph intelligence tool. So we have connected to the database with this particular fraud data, and we can see the schema, which was automatically extracted from this data source. And as I zoom in, you can see how many elements that we have of each type. We can select some of these items. For example, I'm going to select this and say, build me a query. So I don't have to know how to write Gremlin or Cypher queries. I can just create a graph pattern and say, go grab me that. Okay, now on here on the left side, you're going to see the available node types that we have and edge types that we have. Where did that information come from? Did I have to build that by hand? No, I didn't. When we connected to the data source, we automatically extracted the schema, including the model element types and the attributes. So this was all done for me automatically by Tom Sawyer Explorations. And by the way, Tom Sawyer Explorations is an application that we built with Tom Sawyer Perspectives, our graph analysis and visualization platform. All right, so now we are looking at the fraud data. And so I am going to zoom in. And so you see we have different types of elements here, with a high level of precision on how the graph is laid out, where are the nodes placed, how are the edges routed, where are the edge labels. That was all done automatically with our advanced layout technology. We can select certain items and we can see details of them over here in our detail window over here as well. We have ability to set the information that's showing in the nodes. So we can show the text, like for example, we have the transaction and the transaction amounts, and we have the IP address, we have both the node of what kind of data is this, and also what is the actual IP address. All of that we can define here easily. Again, no code here when we're setting the style of the nodes. And we have the ability to set colors as well, where you can choose colors either with our color picker or by entering the actual RGB code or hex code. All right, so now let's zoom back out, and we also have the ability to filter because sometimes you want to see just certain types of data. So I can interactively choose, and you'll see how the visualization will automatically update. And we also can do some analysis. So let's do a little bit of analysis here. So we are first going to apply clustering analysis. So you can see how the nodes changed colors, and the nodes of the same color are more closely related to each other. So we want to understand not only the graph, but what's happening in the graph and what are the important parts that we need to know. But we can see that some parts of the graph are more tightly connected to each other. And so the clusters show us that. And so, we can zoom in to particular parts of the cluster, or we can also go to a particular item in the cluster as well. Okay, so let's zoom back out. And we have centrality analysis as well. So this time we're going to apply a degree centrality. We want to find out who has the most direct connections in this data that we're studying. And so we can apply the analysis and update the layout here. And we can see, here are the most important elements in our system. For example, which is our most important IP address in this system. I'm not going to take time to show this today, but we do have the ability to add tables here as well, where you get to choose how many tables what information you want to have in the tables, and how to organize it. And again, we have videos on our YouTube channel showing how this works as well. And so want to give a little bit more exciting information of something upcoming here at Tom Sawyer Software this year. We have several efforts underway in the Tom Sawyer Labs with several exciting capabilities that are currently under development. And
Janet,
oh, yes,
could I interrupt you for just 1 second?
yes,
Would you mind exporting a TSV file before you quit that demo?
yes.
Sorry to interrupt. Yeah.
Yes, no problem. Can do. Can do. So we have a new annotations capability for Tom Sawyer explorations, which is coming out here later this year. And so I'm going to show a little video here from our preview testing environments. Again, of course, this is all currently under development. But we're going to see how this new annotations capability works. Okay, so I'm going to start this little video. So you'll see that we have here some badges on some of the elements that are showing that there is a particular annotation on that element. So here on the right side, I am typing a little annotation note. We're starting an investigation because we have a lot of activity at a particular IP address. So I'm going to type the note. I'm going to add a categorization for this particular type of annotation. So I'm going to have an investigation category, and I'm going to choose a particular color for it. So as an investigator, I can understand where we have particular types of data. And then you can see here on the right side where we have the listing of the annotations as well, and their different categories. We also have the ability to resolve the annotations as well. So I'll zoom in and we can see which items have which particular type of annotation. I can select and show the annotations only for a particular element that's been selected. And you can see here as well that we have multiple annotations available for this particular item. And so, yeah, let's continue here, and we're going to see how these annotations work with our filtering capabilities. Because again, one of those key parts of effective graph visualization and analysis is to get to the data that you need to know. And so let's see how that works. So we are going to zoom out here, and we are going to apply filters to our annotations. We can apply filters to show annotations happened in a particular time frame. We can show ones that are resolved or unresolved, or only those of a particular type. So we can pick and choose there and see only those particular annotations. So here we filter down to where we see a lot of fraud alerts happening. So here, there's a lot of fraud alerts on this particular account. So we're going to focus in on that, find out what's happening there. We also have the ability to filter what's showing in the drawing view. So we can, for example, say, show me in the drawing view only the places where we have unresolved. Or only where we have annotations, or only certain types of annotations, which we do here. And so you can again see how that is done interactively, no need for writing code. So that is coming later this year from Tom Sawyer Software, one of many efforts underway that we're excited to bring to you soon. So thank you very much for joining us today. We really appreciate you spending your time with us here. We discussed several things today. We discussed our our new FBI case study, which is available on our website on our public sector page. We also talked through several examples of integrating with a wide variety of data sources to do investigations. We looked at some examples of looking at criminal networks and their social networks, as well as applying analysis to some AI results on potential fraud rings that are happening in financial transactions. We also looked at several examples here in Tom Sawyer explorations so that we could better understand our data and uncover hidden fraud or hidden connections as well. And we also talked about the Tom Sawyer Perspectives SDK and low-code development platform, which is used to create these specialized applications that are tailored for a particular use case and particular types of data. So please contact us today at tomsawyer.com to find out more about Tom Sawyer Perspectives and Tom Sawyer Explorations, or to start your free trial. Please reach out to schedule a call with one of our graph and data visualization experts. You can reach out to us on our website or by email, and we can help guide you to the best solution.